All right, so we're doing 2.5, at least as much of it as we can. The one benefit about 2.5 is it's a lot of what we were just doing in 2.4, but we're gonna add in complex numbers. And remember, complex numbers are basically imaginary numbers. So a lot of what we're doing today, you're probably like, oh, we did this the other day. True, but we're adding in the idea that we're having i's and complex numbers and all that fun stuff. And so actually to start out, I have 3 problems here. So essentially 3 types of things that we're gonna learn. And 1 and 3 are very, very similar, but on number 1, on A, B, and C, I'm gonna give you a hint, essentially. I'm gonna tell you what one of my zeros is, so we at least know where we're gonna start. So it says on number 1 for A, B, and C, it says use the given 0 to find all the other zeros of the polynomial. And these are all real, imaginary, rational, irrational, all types of numbers here. So x equals 2, and my function is x to the third minus 6x squared plus 11x minus 6. We do not even need to do PRRs here because I already know what one of my zeros is, right? I know one of my zeros is 2. So I'm ready to just go, and I'm going to just do my synthetic division. So I'm going to have 2 in the house, and I'm going to do my coefficients in front of it. So 1, -6, 11, -6. And it should equal 0 because that's what it's supposed to do. So carry my 1 down, 2 times 1 is 2. -6 plus 2 is -4. That should be -8, which is 3. And 2 times 3 is 6, which is 0. Perfect. Again, they told us it's a factor, so if it doesn't equal 0, that's a personal problem for us, and we have to go figure it out. Now, every time I do my synthetic division and I get 0, now I want to put it in a polynomial so I can do something with it. So I'm going to say that is the same thing as x squared minus 4x plus 3. Whenever I get down to a quadratic, you have 2 choices. You can either factor it or you can do quadratic formula. And I'm going to do, oh, can I factor this?
Yeah.
Oh yeah, we can factor it. So I'm just going to go rewrite it over here because I ran out of space. And we can factor, Quinn, what does it factor down to be?
X minus 1, x minus 3.
Good, x minus 1, x minus 3, which means my zeros are 1, 3, good, and 2. Quinn would not let me forget that we knew 2 from the beginning. So we had 2 to do my synthetic division, and that helped me get my zeros of 1 and 3, but 2 also should be listed on my line. That should be my 0. Cool. All right, I gave us a nice easy softball one because the next 2 are a little bit harder because I've got i's. Look at my next 0. It says x equals 1 plus I. Oh, that is yuck. That is gross. Now, the cool part is, you're like, there's no cool part. I promise there's a tiny cool part. I know another 0 because this is an imaginary number. My conjugate of this is also a 0. What's the conjugate of x plus I? Or sorry, what's the conjugate of 1 plus I?
1 minus I.
1 minus I. 1 minus I. So both of those are going to be zeros. Whenever we have imaginary numbers, you need 2 imaginary numbers to both be zeros in order to essentially cancel it out. So I'm going to do my synthetic division with one of my zeros being 1 plus I, and then I'm not even going to put it in polynomial form. I'm going to immediately do the synthetic division of the conjugate, okay? So I'm going to set it up over here a little bit because I want some space to work. I'm going to do 1 plus I is going to be in my house. I'll put my coefficients out, but I'm going to give a lot of space between them. 1, -2, -1, 6, -6. I know that's very dramatic on how much space I gave them, but I want a lot of space in case with my i's, I need to like make sure that I have everything written correctly. Now also, because I'm multiplying, just like we've been doing with synthetic division this whole time, everything underneath gets multiplied by what's in the house. I'm gonna essentially set up a little work off to the side because I might have to do 1 plus I times something in order to figure out what goes above my line. It's not as simple as just doing 2 times 3 in my head. I'm gonna have to do 1 plus I times stuff. Now, that being said, the first one is pretty self-sufficient because I carry my 1 down, and 1 times 1 plus I is just gonna be 1 plus I. And I'm gonna line up my real numbers underneath each other, and I'm gonna put my imaginary number off to the side. Because I cannot combine -2 and I, but I can combine -2 and 1 to get -1 plus I. Okay. Now though, in order to figure out what goes next on the line, I have to do 1 plus I times 1, negative 1 plus I. Negative 1 plus I. And if you can do this in your head, go for it. I just can't. I feel like I'm going to lose something. So I'm going to put it off to the side so I can keep track of everything. I'm going to FOIL this. 1 times negative 1 is negative 1. 1 times I is I. I times negative 1 is negative I. And then I times I is plus I squared. Now, the good thing about this are my i's are going to cancel. So I get negative 1. And then what's I squared the same thing as? Good. So negative 1 minus 1 is negative 2. Good, so when I multiply those together, I get negative 2. So that goes up on the line next. Negative 1 minus 2 is going to be negative 3. Negative 3 times 1 plus I is going to be negative 3 minus 3I. 6 minus 3 is 3, and then I carry that negative 3i down with me because I have nothing to combine with it. All right, and now I have to do one more work off to the side. I have to do 3 minus 3i times 1 plus I, and then go from there. 1 plus I times 3 minus 3i. Everyone's okay on why I have to multiply those two together? I hope it's going to be nice like the last one. 1 times 3 is 3. 1 times negative 3i is negative 3i. 3i times 3 is 3i. And then I times negative 3i is negative 3i squared. Negative 3i plus 3i is 0. And I get 3 minus 3i. Oh, no, I lied. Because that's negative 3i squared, which is the same thing as Positive 3, good. Going a little too autopilot, I messed up. All right, 3 plus 3 is 6. And if we write 6 up there, oh, thank God it's 6 because that makes that 0. Which again, they told me that was a 0, so it should work. And if it doesn't work, I'd have to go back and figure out because I probably messed up. I would not ever make you like guess and check with these. If I tell you it works, it's going to work. Okay, now. Oh, yeah. It's okay. Now, I am not even going to write this as a polynomial because I've got all these i's in here. I'm just immediately, even just right next to it, I'm going to do my conjugate, 1 minus I. And I'm just going to do another synthetic division right underneath that. If you want to rewrite this line somewhere else, you're welcome to. Like in alpha, my spacing wasn't right, so I had to rewrite it so it was neat enough. But you don't have to rewrite it. It's just right underneath it. And I'm going to ignore this 0 now because that was the remainder. So now I'm going to do these coefficients. I'll start by carrying down my 1. 1 times I minus 1 is 1 minus I. Oh, look how that works out. Negative 1 plus 1 is 0. And then I minus I is 0. Whoa, that's cool. 0 times 1 minus I is still 0. So that means I get negative 3 that comes down. And then negative 3 times 1. And then negative 3 times negative I is plus 3i. So negative 3 and 3 cancel, and negative 3i and 3i cancel. So I get 0 again, which is good because that's my remainder. That's the reason we have to do this in this form. We have to do both conjugates because you will not get answers without i's unless you do both the positive and the negative. So we got to do both. Thank you. Hey, Caitlin, I'll see you. All right, now though I'm all done, I'm gonna write this as a polynomial. So I've got x squared plus 0x minus 3. And now when we've been doing quadratics, we've usually done either factoring or we've done quadratic formula. And here I think I can do it even easier by just setting it equal to 0 and solving, right? If I set that equal to 0 and solve, I add 3 to both sides. And then I square root both sides. So x is going to equal plus or minus square root 3. Now, x equals plus or minus square root 3 is not my only zero. What are my other zeros again? Yep.
1 plus I.
So you're going to say, Ryan? Yeah. 1 plus I and 1 minus I.
I'm so sorry.
Okay. Oh, that was a little tough, wasn't it? Each individual step I didn't think was so hard, but it's doing it all together that I think is what makes it the most challenging. So plus or minus root 3, 1 plus I, 1 minus I. All right, we got one more like this. Are you ready to do one more together? Okay. This is another one with I. It says x equals 4i. We also know that its conjugate is going to be a 0, which makes what another 0? What's the conjugate of 4i? Negative 4i. Very good, Ryan. Negative 4i. Good, so we're going to do synthetic division again. We're going to do 4i, and then immediately after, we're going to do negative 4i. This one is slightly easier, one, because we just did a problem like this, so this isn't the very first time we've seen it, and B, we're not adding or subtracting, so our multiplying is going to be a little bit easier as well. So I'm going to do 4i first. 1, 13. Oh, I made a mistake, right? We got to put a 0 in because I've got x to the 4th and then x squared. So I got to do 1 and then 0 and then 13 and then 0 and then negative 48. Thank you so much. Anybody questions yet? Doing okay? All right, carry my 1 down and synthetically divide. You guys are really rocking that. 1 times 4i is 4i. 0 plus 4i is just 4i. 4i times 4i is going to be 16i squared. And I squared is negative 1, so that's like negative 16. Did I do that too much in my head, or are we following? Okay, good. If not, just yell at me and I'll slow it down. So 13 minus 16 is negative 3. And then 4i times negative 3 will be negative 12i. And then 0 plus negative 12i is negative 12i. And then 4i times negative 12i will be negative 48i squared, which will be positive 48. Oh, which works out nicely. Which again, it should, because they told us it's supposed to. And then just like last time, I'm not going to write this as a polynomial. Immediately underneath that, I'm going to do negative 4i. And I am going to cross out the 0 because sometimes I want to include 0 in it, and he's a remainder, so I don't get to include it. So I'll carry my 1 down. Negative 4i times 1 is negative 4i, which is 0. 0 times negative 4i is 0. So negative 3 comes down. Negative 3 times negative 4i is positive 12i, which is 0. Perfect. I got to put this in a polynomial, so I've got x squared minus 3 equals 0. Now, someone last class was like, is it always going to be like that? And I said, no, it just happened twice in a row to end in x minus 3. That's just a happy coincidence. A lot of times they will end in x squared and then plus or minus 1 number, though. Mm-hmm. So if we would have put a number on the second line, this would have been x to the 3rd. And then we did 1 more after that, so that's why we got x squared. Yes, great question, Donna. So since I did 2 synthetic divisions, I got to go 2 exponents down from where I was. All right, and then we solved x squared minus 3. We just did that a second ago. Make it x squared equals 3. So x is going to equal plus or minus root 3. In addition to this, my other zeros are those ones that I used in my synthetic division. My 4i and my negative 4i. And so I could write that as positive or negative 4i, or you can write it as 2 separate terms. That's totally okay. All right, what questions do we have? Anybody have any questions yet? Okay. All right, we're gonna do one more skill that's a little bit different, and then I hope to at least get 3A done. If we don't, I did video all of number 3, so you can always watch that next class. So we at least need to get all of number 2 done. So this says write the polynomial function, and it says multiply it out. So I don't want it as like x plus something, x minus something. I want it to be like really multiplied out. That being said, when we did our polynomial functions before, we did like y equals, and we'd be like x minus the 0. We'd be like x plus a 0, right? And we'd have like as many parentheses as we needed. Now, the one thing I want to add in this time is I want an A out front because I want a constant. The reason I know I need to use A here and we didn't use A on the other ones is it says it contains this point. That means there's going to be some kind of stretch shrink factor that we got to take into consideration, which is that variable out front. And I'm going to plug -1 in for my X, and I'm going to plug 8 in for my Y at a certain point. That being said, let's start it in factored form because we got to start somewhere. Okay, my zeros are 2 and I. Ooh, there's one more 0 that they didn't tell me, but I know. What's that other 0? Negative I. Very good. We got to do the conjugate. So I've got 2 and I and negative I. Don't forget the conjugate and the imaginary number go hand in hand. So I'm going to set this up as y equals A times x minus 2 times x minus I times x plus I. Now, we can do this a couple different ways. One thing we could do is just plug our x and y in here and simplify from there. However, the directions say multiply out, which means at some point I'm going to have to multiply everything out. So let's start doing that now. Also, it'll make it way easier if I plug in x in like one expression instead of all of these different parentheses. So let's start by combining these two. We're going to combine x minus I and x plus I. And it's going to get rid of the imaginary numbers super quick. So my y, my a, my x minus 2, I can't adjust those. X and x times x is x squared. X times I is xi. And then negative I times x is negative xi. And negative I times I is negative I squared. So I did this times everything, and I got those two. And I did this one times everything, and I got those two. This is awesome, though, because I can cross out my xi's, positive and negative. And remind me, what is negative I squared the same thing as?
Oh, positive.
Positive 1.
I use a restaurant.
I squared is -1, so negative 1 is positive 1. All right, and then let's multiply that by my x minus 2. That one's going to be a little bit simpler. It just becomes x to the third minus 2x squared plus x minus 2. I said that was really simple, and then I really just stumbled through that. I'm so sorry. That was embarrassing. It was hard going like foiling backwards. Okay, so I did x squared times everything, 1 times everything, and that's what we got. Okay, now is where I'm ready to plug my x and y in. So I'm going to plug -1 in for all those x's. I'm going to plug y in for 8 in for y. So 8, and that equals a times -1 to the third minus 2 times -1 squared plus -1 minus 2. So we start simplifying. -1 to the third is -1. -1 squared is positive, and positive 1 times -2 is -2. That's -1, and that's -2. -1 minus 2 is -3, minus 1 is -4, minus 2 is -6. Am I moving too fast, or are we doing okay? Good, okay. And then we just divide to get a by itself, -6. And so that'll be -4 thirds equals a. Now it does say right in the polynomial form, and it says have it multiplied all the way out. So one reason I made us multiply it all the way out over here is because now I'm going to put -4/3 in for my A, and then I'm going to distribute that -4/3 to everything. So I'll put -4/3 in here, but then everything else is going to stay the same. And I'm going to distribute that out. So y will equal -4/3 x to the third plus 8/3 x squared minus 4/3 x and then plus 8/3. How are we feeling? Okay. That was a lot. Yeah. For something that should have been really easy, right? It feels like it should be a much simpler problem. And I don't think anything was too tough. I really think pre-cal is hard just because there's so many things to do. I don't think anything in particular is more difficult than anything you've ever done. I think it's just I make you do what you would do in 4 problems in Algebra 2 in 1 for pre-cal. That I think is the hardest part. Okay, we're going to do a very similar thing for the next one, but my 0 is a 1 plus 2i. What would that mean my conjugate is over there? 1 minus 2i, right? I know we're kind of tired. Is everybody okay with that? It's 1 minus 2i. Okay. Now that being said, I'm not releasing you yet because I want you to do this. Normally I do a second problem. I'd be like, you guys try it on your own. I don't want you to try it on your own because when you write this in, we'll write x minus 1. And then to represent this as my 0, I have to do x minus 1 plus 2i. And I have to do x minus 1 minus 2i. Sometimes with the conjugate, you're like, oh, it's just plus and minus. Not when there's other pluses and minuses involved. I'll distribute this negative throughout. So technically, if you are okay going straight to the second step, I'm okay with that too. X minus 1 minus 2i, and then x minus 1 plus 2i. See where the plus and minuses come in here, but the 1 is always minus. As long as you're okay with that, I'm okay with that. And can you do those two? Thank you so much. Okay, yeah, thank you. Bring it to me. All right, we good so far? Now, just like last time, we're going to multiply it out. And if you thought last time was a little extra, this one's even more because I have to do 3 of these. So I have to do x distributed to everything. I have to do -1 distributed to everything. I have to do positive or -2i distributed to everything. So I'm going to do a little color coordinating because that helps me keep things in order. So I'm going to do x times everything. So x times x is x squared, x times -1 is -x, and then x times 2x or 2i is 2ix. So that's what I got when I multiplied everything by x. Now I'm going to multiply everything times -1. So -1 times x is minus x. -1 times 1 is positive 1, and then -1 times 2i is minus 2i. So that's what I got by multiplying everything times -1. And last, I'm going to multiply everything by -2i. -2i times x is -2ix. -2i times 1 is plus 2i, and then -2i times positive 2i is minus 4i squared. All right, again, that's a lot, but what I'm about to do is simplify. I'm going to combine like terms, and I am going to cancel a few things out. So I've got y equals a times x minus 1 because I still haven't messed with him yet. My x squared has nothing to combine with, so I'm going to just write my x squared down here. And then I'm just gonna cross him out because I don't want to think about him anymore. All right, now I'm worried about my x's. I've got negative x and negative x, so that's gonna be minus 2x. Then I have 2xi or 2ix. Oh, and I've got a negative 2ix, so those completely cancel out. I'm gonna worry about 1 in a second. And next I've got negative 2i and positive 2i, so those cancel out. I left 1 still in that expression because I'm gonna combine 1 and negative 4i squared. What's negative 4i squared the same thing as? What's I squared the same? Oh, 4. Very good. Positive 4. And so 4 plus 1 is 5. Okay, cool. That was a lot, but it simplified down really nicely, right? That being said, we got to multiply this quadratic times x minus 1. So I'm going to do the exact same thing again. I'm going to distribute x to all of those pieces and negative 1 to all of those pieces and see what we get. This time, I am going to get rid of that x minus 1 because I'm multiplying it out. So I get x to the third minus 2x squared plus 5x. And then now negative 1 times all of that, so negative x squared plus 2x minus 5. And now I get to combine. X to the third is by itself. Negative 2x squared minus 1x squared is going to be negative 3x squared. I've got plus 5x plus 2x is plus 7x, and then minus 5. And we did all that work, so now we're going to plug in our x and our y. So I'm going to plug negative 1 in for my x, and I'm going to plug 4 in for my y to find my a, and then plug it back in like I just did before. This I will kind of like release you to try on your own, because that was, we did the messy part together. Kids are insane over there. So 4. -4 minus 7 is negative 11 minus 5 is negative 16. No. See, Mom? Did you get them all? Yeah. Okay. All right, and now I gotta plug that negative 4 in for my a and then solve for the rest of it. So I've got y equals negative 1/4 x to the third minus 3x squared plus 7x minus 5, and distribute that negative 1/4 through. So y equals negative 1/4 x to the third plus 3/4 x squared minus 7/4 x plus 5/4. Okay. Whew, that's tough. I think we have time for one more though. What is happening? That girl does not think we have time for one more. I'm gonna just close this door. Slightly better. Okay, this last one is just like number 1. It's like the ones we were doing earlier, but I didn't give you any hints. I didn't tell you what any of the zeros are, so we're gonna have to review. We're gonna have to redo all those zeros. We have to figure it out on our own. Remember, we have the steps kind of written off to the side somewhere, and I'm just gonna briefly review them very quickly with you. So my steps were, if we could factor first, we're gonna do that. So always look to factor. Can I factor this guy? No, right? Because he's an x to the third, not an x squared. So that's a bummer. That's all right. Instead, we'll do PRRs. And then once we do our PRRs, then we'll do our synthetic division. Sometimes we may need to go back to the PRRs. I'm going to tell you in letter C in the video that you'll watch next class. We'll have to go back to do more PRRs before we can carry on. But most often we are done with synthetic division and then we can simply factor or quadratic formula and then be totally done. So let's do that here. Remind me, what are my PRRs? Or what do I do to find my PRRs for this problem? Quinn?
The factor to the constant.
Good, which is?
1, 5.
Good, 1 and 5 are my factors of 5. And then what is that divided by?
Factor to the coefficient.
Good, which is 1. Which you didn't have to be dramatic like I did. You could just write plus or minus 5 because anything divided by 1 is just itself. Now, once we have our PRRs, we got to do synthetic division to figure out which one works. Now, I will give you a hint. This one works the first one we try. We're going to try 1 first because I always try 1 first. Remember, when you do this, we need to have a 0 in for your x squared value. So I have 1, 0, 4, and then negative 5, and then we synthetically divide. 1, 1, 1, 5, 5, and 0. If we were trying this to see if it worked, we would say it works because we got 0. And then now I'm able to just take the polynomial from this. The only reason we did 2 synthetic divisions in a row were because they were imaginary numbers. If it's normal numbers like this, we can go ahead and put it in a polynomial form and then go from there. Now this is cool because we have just a normal quadratic. So at this stage, you can either factor or quadratic formula. I will tell you that quadratic formula is what we want to do here because this will not factor. And you guys know quadratic formula. So -1 plus or minus 1 squared minus 4 times 1 times 5 all over 2 times 1. -1 plus or minus 1 minus 20 over 2. -1 plus or minus -19 over 2. The only thing we can simplify there is a negative under my radical becomes an I. So x equals -1 plus or minus I root 19 over 2. I'll keep that zoomed in. That's my 0, but there's one thing other that's a 0. What is it?
Afternoon with the road, 3:14. It's starting to rain a little bit. You sure need the rain.
1.
Just be careful driving home.
So whatever we found in that synthetic division, we
Special
need
day for seniors tomorrow with all senior math. Should be special opportunity for all of you. The rest of us will go ahead.